Namaste everyone. So in this video I am going to learn about trigonometric identities in Introduction to Trigonometry chapter. So what are trigonometric identities? You can see there are three trigonometric identities here. One is sin square a plus cos square a equals to 1. 1 plus tan square a is equal to secant square a, and 1 plus cot square a equal to cosecant square a. First of all, before I start, so in this video I am going to learn how you got these three identities, proofs you are going to learn. This they may not ask in the exam, but you have to know how you got these three identities. So before I start the proof of these identities, let me explain or ask the question, what is identity? Just 2 minutes, recall what is an identity. Your teachers might have explained you what is meaning of identity. Just recall. Got the answer? So, okay, let me explain what is identity. So, all the statements are identities, like you learned algebraic identities. Many identities you learned, like example, a plus b whole square, a minus b whole square, a square minus b square, a plus b whole cube. All these are identities. Why they are identities? Why we call them as identities? Why not all are not identities? So, let me give one small example. Okay, as you learned, a plus b whole square, you know it is a square plus 2ab plus b square. So all will agree that a plus b whole square equal to a square plus 2ab plus b square is an identity. If I give another statement, just check it out whether it is an identity or not. If I ask you a square equals to b square plus c square, is this an identity? Okay, I'll agree this is an identity, is an algebraic identity. Now I'm asking one question, is it an identity? No. Why it is not an identity? Because this statement is not true. LHS and RHS are not true for all the real numbers. So it may be true for one or two numbers, but not for all. But whereas identity, this identity is true for any values of a and b. You check this left hand side and the right hand side of this statement, they are equal for any values of a and b. Any value you take in place of a and b, any real number if you put, they will be, means any integers, you can see that left side and right side value will be equal. But whereas if I tell you here, if I take a as 1, if I take a as 1, b as 2 and c as 3. So if you check, LHS and RHS are not equal. So if I take a as 0, b as 0, c as 0, or a as 1, b as 1 and c as 0, then they may be equal. But this statement is not true for all the values of a, b, c. Any value if you take, any real number if you take, they are not equal. That's why this cannot be an identity. So understood what is the meaning of identity? Identity is a statement which satisfies for all the values, that is all the variables in the statement. So here you have two variables a and b. This should satisfy for any value of a and b. That's why it is called as identity. Now let us move further. Another concept of identities, that is trigonometric identities. Three trigonometric identities. This learn carefully. Next, the last exercise of this chapter is totally based on these three identities, and with every identities you get again simplifications. That also you have to remember. And in this concept, the identity concept in this chapter, one question is compulsory for your board exam for 4 marks. You have 10 questions in the last exercise. Among 10, any one you will get for board exam. So let us start now one by one proofs. Now let us prove the first identity, that is trigonometric identity, that is sin square plus cos square equal to 1. So let us consider one right angled triangle, that is ABC is a right angled triangle where angle B is 90 degree. Now I am considering A as acute angle. As you know that according to the acute angle, you can decide what is adjacent and opposite. Hypotenuse will be, as usual, it is fixed. Longest side is the hypotenuse. The other two sides we have to decide according to which angle you have taken as a acute angle. So here I am taking A as, even C is also acute angle, but I am writing trigonometric ratio with respect to A. That's why the angle A opposite side is BC. So consider BC as opposite and AB as adjacent, and as usual you know AC becomes hypotenuse. Now let me prove sine square plus cos square is 1. So as you know, the first thing you get to your mind when you say a right angle triangle is what? That is, yeah, exactly, it is Pythagoras formula. So let us write the Pythagoras formula. You know that it is hypotenuse square equal to base square plus perpendicular height square. So here I can write, in other words, AC square equals to AB square plus BC square, or you can write AB square plus BC square equal to AC square. So AB square plus BC square equals to AC square. So this is trigonometric, it is a Pythagoras formula in this triangle. So that is AB square plus BC square equals to AC square. So however you want, you can write left side or right side, you can interchange. So AB square plus BC square equal to AC square. So what is the next step? Divide all these terms, divide this Pythagoras formula by AC square. What happens? Let us check. Divide each term of this by AC square. So what happens? AB square plus BC square equals to AC square. So for all these terms, divide by AC square. AC square, AC square, AC square. Next, what we can do? You can cancel AC square and AC square. You get here 1. But here you cannot cancel. But what you can do from this? So I can write AB by AC whole square. Yes. Plus BC by AC whole square equals to, so already I got 1. So we got AB by AC whole square plus BC by AC whole square equals to 1. Next, what next? You can see here AB is what here? In the diagram, what is AB? AB is adjacent. So adjacent, and AC is what? Hypotenuse. So we have here adjacent by hypotenuse whole square plus BC is opposite and AC is hypotenuse. So opposite by hypotenuse whole square equals to 1. Now you just recall the trigonometric ratio. Adjacent by hypotenuse is what? So exactly cos. So cos square A. Why I am taking A? Because acute angle I am taking as A. So cos square A plus, what is opposite by hypotenuse ratio? Sin. Sin square A equals to 1. So in other words, you can write sin square A plus cos square A equals to 1. So this is a proof for the first trigonometric ratio, that is sin square plus cos square equals to 1. So I will repeat in brief. So consider any right angle triangle. Here I have considered ABC as a right angle triangle. B is 90 degree. And apply the Pythagoras formula and write down the Pythagoras formula. AB square plus BC square equal to AC square. Divide this by hypotenuse, that is AC. So divide each term by AC square. We got AB by AC whole square plus BC by AC whole square equals to 1. And here you have AB is nothing but adjacent. Adjacent by hypotenuse whole square plus opposite by hypotenuse whole square equals to 1. That is cos square A plus sin square A equals to 1. In other words, you can write sin square A plus cos square A equals to 1. Now we proved that sin square A plus cos square A equals to 1. So with this identity can be reduced into two other forms. What are the two terms you have here? Sin and cos. So you can convert this. This will be very, very helpful when you solve any question related to trigonometric identity. So under this you can write two more reduced identities. So how you can write? One thing you can write sin in terms of cos, and the other thing you can write cos in terms of sin. So very easy. From this only you can simplify and you can reduce. So first you take, now I am trying to write sin in terms of cos. Means what? Sin should be alone and RHS it should consist cos also. So first let us write this. This is clear as we know already one identity we proved, sin square A plus cos square A equals to 1. So let me write this as sin square A equals to 1 keep as it is on the right side, and this cos square a is bring to right side. So minus cos square a, because you have here plus. So when it goes to another hand, it becomes negative sign. So sin square equal to 1 minus cos square a. So now still what you can do? So you can write as sin a. This square if you remove, so you know that when a square equals to 4, what is a? This 2 when you send to another side becomes power half. That becomes square root of 4. So in the same way here also, when you send 2 power 2 on RHS, it becomes square root of 1 minus cos square a. So you can write plus or minus also here. So this is the another formula where you can write sine in terms of cos. So this is an identity which is reduced from the first identity. So you can write sine equal to square root of 1 minus cos square a. This you have to remember. So when you see the question, you cannot write there. It takes time. So instead of that, better to remember all these reduced identities also. The second one, the next reduced identity. Again, first, just now we proved sine in terms of cos. Now let us make cos in terms of sine. So what happens? The same identity, you make cos alone on left side. So cos square a equals to 1 is as it is, and send now sine square to right side. It becomes minus sine square a. So now again remove the root. It becomes cos a equals to root of 1 minus sine square a. So these three you have to memorize. Under one identity you got another two reduced forms. So for first main identity is sine square a plus cos square a equals to 1. The another one is sin a equals to root of 1 minus cos square a. And the next one cos a equals to root of 1 minus sine square a. So these are the three identities, two identities under the first identity. Now let us prove the second trigonometric identities, that is 1 plus tan square equal to secant square a. So same as it is, take a right angle triangle, right angled at B, and here you can see it is opposite, adjacent and hypotenuse. So first thing you have to write the Pythagoras formula. So AB square plus BC square equal to AC square. Before we divided throughout by AC square, so we got the first identity sin square plus cos square is 1. Now let us divide it by AB square. So what happens? Let us check each term by AB square. So AB square by AB square plus BC square by AB square equals to AC square by AB square. So you can see here AB square and AB square gets cancelled. So we got 1 plus. What is BC square by AB square? How will you write? BC by AB whole square equals to AC by AB whole square. Just look at this 1 plus. What is BC here? BC is opposite divided by AB is adjacent whole square equals to AC is hypotenuse divided by AB is adjacent. So we got hypotenuse by adjacent whole square. So now let us convert into ratio. So 1 plus, what is opposite by adjacent? So trigonometric ratio, recall opposite by adjacent is exactly tan. So 1 plus tan square A equals to hypotenuse by adjacent, that is reciprocal of cos, that is sec square. So it becomes sec square A or secant square A. So this is the proof of the second trigonometric ratio. So we got 1 plus tan square A equal to secant square A. Now let us reduce this identity to two more another forms. So because it is required for your any question if we solve related to this identity, so we require this reduced forms. So let us learn that. So let me reduce this 1 plus tan square equal to secant square is the main identity. From this what I can do? So I can write send secant square, let it be as it is. 1 Here let it be as it is. Let us send tan square to this side. What happens? 1 equals to secant square A minus tan square A. So let us rewrite this as secant square A minus tan square A equals to 1. So this can be one of the reduced form of the second identity. So what I did? 1 you write as it is, send tan square to right side. Secant square will remain there only. So secant square minus tan square. Reverse it, you can write secant square minus tan square equals to 1. So if you remember this directly, you can substitute in your given questions and you can utilize this. And the next one, we have 1 plus tan square is secant square. Secant square A minus tan square A is 1. So next what we can do? We can write tan in terms of sec. This is already sec in terms of tan. One more you can write tan in terms of sec. So from this tan square A, make it alone. Tan square A equals to secant square A plus 1 becomes minus 1. So tan A equals to when you send this root here becomes square root of secant square A minus 1. So this is called tan in terms of sec. So tan A send to this side. So we got from here tan square A equal to secant square A minus 1. So tan A equal to root of secant square A minus 1. Similarly, you can write one more thing here. Is already sign in terms of tan. If you send 2 to this side, so what happens? Again I will write directly, I am writing. So sec A will be on one side and the power of sec, that is 2 when it goes to this side. What happens? Sec A equals to square root of 1 plus tan square A. So this is another reduced form. So with this is a main identity. Once you remember the main identity, so even though you can't memorize this, you will get automatically when you solve from this. So with this I completed second identity. You learn how to prove it. That is 1 plus tan square A equal to secant square A. From this, keep it in your mind. All this you can write secant square A minus tan square A equals to 1. Tan A equals to root of secant square A minus 1. Sec A equals to root of 1 plus tan square A. Now let me explain you the proof of the third identity, that is 1 plus cot square A equal to cosec square A. So now again same triangle, you take triangle ABC, right angle at B. So write the Pythagoras formula, AB square plus BC square equal to AC square. Now the remaining, the third one we have to divide is divide by BC square. So now let us divide throughout all the terms by BC square. So AB square by BC square plus BC square by BC square equals to AC square by BC square. So here you can cancel. So write AB by BC whole square plus 1 equals to AC by BC whole square. Now what is AB? What is AB here? AB is adjacent by BC is opposite. So adjacent by opposite whole square plus 1 equals to AC is hypotenuse and BC is opposite by whole square. Now let us write the trigonometric ratio. So what is adjacent by opposite? So it is a reciprocal of tan, that is cot. So you can write cot square A plus 1. You can write cot square A plus 1 equal to hypotenuse by opposite is cosec. Cosec square A. So you can rewrite this 1 plus cot square A equals to cosec square A. So this is the third identity. 1 plus cot square A equal to cosec square A. Now let us learn from this how can you reduce this formula, reduce this identity into another forms. So already you can see here cosec is alone. So let us write first cosec in terms of cot. So when you remove this 2, it goes here, it becomes square root. So I can write this as cosec A equals to square root of 1 plus cot square A. So this is one form. Cosec A equals to root of 1 plus cot square A. Next, if I make 1 alone on one side, so what happens? So 1 remains as it is. Mind calculation you do. So I can write, send cot square this side. It becomes cosec square A minus cot square A. This one if I reverse, what happens? Cosec square A minus cot square A becomes 1. So when you simplify, you get this. Cosecant square A, keep 1 as it is here, send cot square to right hand side, becomes cosec square A minus cot square A, and then reverse it. Cosecant square A minus cot square A equals to 1. Next, we have here cosec in terms of cot. Let us make now cot in terms of cosec. So for that, what I have to write here? Cot square A equals to cosec square A minus 1. Plus 1 becomes minus 1. Now make cot alone. So cot A equals to square root of cosecant square A minus 1. So this is another form, that is cot in terms of cosec. So with this third identity, the main identity you have to remember, 1 plus cot square A equal to cosecant square A. That is, another form is cosec in terms of cot, then cosecant square minus cot square equal to 1. This is cot in terms of cosec. So with this, I completed all the 3 proofs. The first identity, that is, we learned sin square A plus cos square A equals to 1. The second identity is 1 plus tan square A equal to secant square A. And the third identity is 1 plus cot square A equal to cosecant square A. So remember the main 3 identities, then automatically you can reduce them into another form. So I hope everyone understood. Next class, be ready with these 3 identities, specific angle table, and also trigonometric ratios, reciprocals. So all these you should be ready, so that we have to use all this to solve the next exercise. That is, exercise 8.4 is very, very important. You have 10 questions there which is involved with all. We can use this trigonometric identities, these 3 main identities. So I hope everyone following all these sessions. Thank you.